Welcome back to the Mob Mentality Show. My name is Austin Chadwick and co-host is Chris Lucian. And today, very excited to have Dave Farley joining the show. So we're here to talk about several great topics like continuous delivery, modern software engineering, hyper-agile context, automated testing, TDD, BDD, etc. So lots of great stuff lined up here. But before jumping into those, Dave, do you mind giving us an introduction for yourself?
No, and thanks for asking me on the show. My name is Dave Farley. For people that like Sherlock Holmes, I refer to myself sometimes as a consulting software engineer because it's the kind of humor that I have. But I'm a long-time software developer, mostly at the kind of slightly more complicated end of the spectrum, building detailed techie things. I ended my career writing software, largely doing high-performance finance systems, building exchanges and trading systems and stuff like that. And I'm probably best known as the author of the Continuous Delivery book, and maybe these days as the host of the Continuous Delivery YouTube channel, which has hundreds of thousands of subscribers and millions of views. My interest in software development is really about the things that are durable and that we can kind of have an impact on the way in which we all work and allow us to build better software faster. And that's the stuff that really kind of gets me interested and excited in things.
Right on, right on. Well, I guess to kick us off, in the world of continuous delivery, what are you passionate about lately? What's going on with you?
I think one of my heresies, I'm a natural heretic, and one of my heresies is that I don't think our industry changes as fast as we think it does. And so I don't think there's anything deeply new that is exciting about continuous delivery. There's always some nice tools coming along and so on, but the principles are what really matter. And the thing that's exciting for me are the way in which continuous delivery is being adopted increasingly in really quite extreme circumstances. For example, SpaceX are a continuous delivery house. They deliver software to their space rockets, and they're updating the software on their space rockets 45 minutes before a launch. That's pretty damn cool, in my opinion.
Nice. Yeah. And so, I mean, what comes to mind with an example like that is risk, right? So some people might think like, oh, continuous delivery, that sounds great for, you have an e-commerce website where if something goes wrong, not too big of a deal. What about, are there ways to do continuous delivery where it's very dangerous and, or ways where it's much safer? And what have you seen being the differentiator for that?
There are certainly ways of doing it more dangerously. Like anything else, human beings are very talented at finding ways of messing things up, and so we can certainly find ways in which to do it wrong. So if you are continuously delivering software into production that you're not evaluating, not testing, it's not what I actually call continuous delivery, but if you're doing that, you're probably being very risky. But the counter to that is that what we've learned, what we have data to demonstrate through the work of the Dora group, and that's published in the Accelerate book and those sorts of things, is that working in small steps is the safer route. So this isn't about taking more risks, this is about reducing risk. And that starts to be fairly obvious when you think about the way that it works. If we're able to make changes to our production system in tiny little steps, then each of those tiny steps is simpler and therefore less likely to harbor something nasty. And if it did harbor something nasty, it's probably easier for us to see it and easier for us to back away from it if we find a problem. So my flavor of continuous delivery is largely, as I said in the opening, where my career came from really is in more complex systems, but really thoroughly evaluating those as far as we're able to before launch, but very quickly and very efficiently, and then monitoring them very closely in production. And if we do see a mistake, we're able to pull it really quickly and recover from it. This, it turns out, is quite dramatically safer as a strategy than thinking really hard, moving really slowly, and testing big complex changes altogether and crossing our fingers that there's nothing nasty in there, because there very often is. And so the data says that the faster you go, the less risk, not the greater risk, which is why SpaceX want to be able to updating their space rockets minutes before a launch.
Nice. Yeah. And I think I've definitely seen both worlds. Early in my career, it was definitely the large batches. And, if you're testing it, manually, or even from an automated perspective, it's like something goes wrong and you're like, okay, well, it could be one of 100 things. Let's dig in and find out which one. And days later, you might find out, right? And I love it. I think you've said it this way before, Chris, like lean is cathartic, right? And so there is this like Zen that I just absolutely am addicted to with continuous delivery and XP and things like that, is that if you're doing all these little small pieces, it's just so much more peaceful, right? Because like you said, if the pipeline breaks, or something goes wrong, it's like, it was just the last thing we did, which was really small, which is easy to revert or easy to fix, and so I think it's like the emotions and the objective safety seem to go 1 and 1 for me. So maybe a follow-up question would be, what have you seen out there as far as barriers for people kind of embracing this Zen of the small steps? What are the barriers that you've encountered?
I think they're fairly significant, and as usual, it's a people problem. It's not technology. So we can do. There are organizations, there are world-class organizations that are doing continuous delivery in defense settings, medical settings, heavily regulated industries of all kinds, finance, big web shops, massive scale, global scale, and hardware devices. I have a client that I was working with for a few years building very complicated scientific instruments. They're building a whole software stack from firmware up. And so there's nothing technical. There aren't any technical barriers as I can see. One of the companies that I came across was doing continuous delivery with COBOL systems on mainframes. So there's not technical barriers. The barriers are cultural and organizational. So the biggest hurdles that I see in certainly larger organizations, the kind of organizations that these days I tend to consult in, are largely in 3 groups. The first one is that requirements are usually wrong. So the requirements process is usually deeply broken and has turned into kind of programming by remote control, where the requirement isn't a requirement at all, it's a specification of a solution. And the next one is a problem of coupling. So we, people, big organizations with too much money, throw people at a problem, divide the problem up into teams, but leave the teams coupled so that they're technically coupled, organizationally coupled, so one team can't make changes without having an impact on another. And then the last one is automated testing, so reliance on manual testing, which is too slow, too low quality, too expensive to do a good job. So if you start cutting away at each of those things, you start getting effective changes. But certainly in larger organizations, you start touching on, people's sense of security in their jobs and the politics of an organization. If you're a middle manager in a big bank, then you're often judged by how many people you manage. If and therefore bigger teams is a good thing from your point of view, not a bad thing. And if you are working in that kind of environment where, it takes you months or sometimes even years to release software, it seems impossible to imagine being able to evaluate your software and getting an answer back saying, yeah, it's releasable at least once a day, which is my definition of continuous delivery. And so these things are difficult, and so you're in this game of trying to achieve this I would argue a genuine paradigm shift. This is a genuinely completely different way of thinking about and approaching software development, and you're trying to adopt that in an organization that has grown up and evolved thinking in a very different way, and that's incredibly challenging for people. So it takes a long time for people to adapt. So it's nearly all a people problem. There was a great article in the Harvard Business Review a couple of years ago, and I'm going to mess it up by not remembering it properly, but it said something along the lines of the barrier to agile adoption isn't whether it works. It isn't the context of of the organization. It's not how effective it is. It's the behavior of executives. It's the barriers in people that stop us adopting these better ways of working. And that's true. That was true of lean for a very long time. I think lean has largely taken over manufacturing, but certainly in bigger manufacturing industries. But we've still got a way to go with software development. But it's the same kind of challenge, and it's a difficult one. I think one of the interesting things, if you don't mind me being philosophical for a moment, one of the interesting things is that I think that one of the things that the software industry has done has kind of stressed and pushed the boundaries of business. So business operated for a couple of 100 years on reasonably similar kinds of lines. You can argue that the production line and Taylorism in the 20th century sort of moved things on a bit and so on, maybe. But largely, it was very similar in terms of the way that things are organizing. And then us crazy people came along building software, and we started stressing it, because that stuff just doesn't work very well for us. Yeah. Ours is a creative activity, and it's a creative technical activity, which is really difficult to do well. And so we stress all of this thing, and we got all these people that are kind of grow up with regular business and production lines in the back of their heads, because that's what they learned worked, and they try and apply that to software, and none of that stuff works. So we have to throw all of that out, and we have to do something else.
Yeah, and I think in universities now, I think business students are finally being told there's a difference.
Yes.
So maybe that's where we're at right now as an industry, is that all of the up and coming business students are at least have a hint that things are different between the disciplines. Yeah. And it is like a largely systematic problem across many disciplines and power influences and things like that. I've seen kind of grassroots movements work too, but it heavily dealt with influence and influencing up and around. And I guess, how would you say you would recommend to people going about trying to change these systems, or is it just something that somebody at the top has to make a decision, or strategically speaking, what would you recommend to somebody that maybe finds themselves in a situation trying to move toward better?
It's incredibly challenging, but there's a bunch of things that I think that we can do. If you'll forgive me telling a joke, that I think there are largely. So Martin Fowler says you either change the organization that you work in, or you change the organization that you work in. Which is a good starting point to think about, but realistically, if you are in an organization, if I'm right and what we're talking about here is a genuine paradigm shift, then by definition what that means is that the rules of the old paradigm don't apply to the new paradigm, and the rules of the new paradigm don't make sense in the old paradigm. That's what a paradigm shift is. And so what that means is that fundamentally, to make this change, at some point, you've got to break the rules of the old system. You've got to break the rules of the old paradigm. And so if we think about that, there are two strategies. You either do it with enough senior top cover that somebody important is going to allow you to break the rules and not fire you, or you do it stealthily so that they don't notice, and you hope that by the time that somebody important that can fire you notices, they realize that what you're doing is actually working. And basically those seem like the two strategies to me. It's and you can get the optimistic part of this is that even if you don't get to the nirvana of world-class performance in what I would term continuous delivery, there are still huge advantages. World-class performance is literally orders of magnitude and more better in quality and productivity when you start looking at comparable teams. That's the kind of level of performance. So it has a real world commercial impact, and that's one of the reasons I think why adoption is accelerating and is growing. And it affects the bottom lines of the companies that undertake it. That's what the State of DevOps report and the Dora Group found in their research. So if you are making those, if you're getting to that high ground, it's all fantastic and wonderful, and people love working in these organizations and produce better software faster and all that sort of stuff. But even if you don't do that, I think that there are some deep fundamental principles about why this stuff works better than the alternatives. And those principles just work. So even if you do it on a small scale, just within your team, you're going to get better. You're going to be doing a better job than if you don't. That's what I believe to be true. So, if you'll forgive me being silly, if you're not using source control yet, then catch up to the 1980s, start using version control, and your life's going to be better. If you're not doing test-driven development yet, catch up to the 1990s, start doing test-driven development, your life's going to be better, and so on and so on and so on. And we just start building those things. So one of the things that we as individuals can do is start waiting for permission to do a good job from somebody else. Yeah. Take that professional duty of care, that responsibility on board, and we'll do a good job for our own pieces of work. And then we'll try and reach out, we'll try and influence our organizations, we'll try and change them, but we're not going to wait for that to do a good job. So just as a simple example of that, if somebody comes to me for an estimate for some piece of work, I'm not going to parse my estimate and give them an option. I'm not going to say, well, if you'd like me to do testing, it's going to take me longer and I'm going to take extra time. Or if you'd like me to avoid refactoring, I can cut corners. I'm not going to do that sort of stuff. I'm going to say what I believe it's going to take me to do what I think is a professional job. And a professional job means I'm going to do my damnedest to build high quality software that I can come back to weeks, months, years later and still change safely. Mm-hmm. And that's important, that ability to kind of sustain that level of progress. That seems important to me. So I'm not going to cut corners for a 1 or 2 week gain when I know that over 4 weeks or years my approach is dramatically faster. So that's what I'm going to go for.
Everybody's inclined to sell themselves short on the short term because everyone waiting for that thing is just going to ask for it up front. And I see that very frequently. I think also, just speaking of mob programming and continuous delivery, I have seen mobbing naturally introduce continuous delivery. I was kind of part of that, where we went from many bugs down to 0 and everything began to get unit tested, and then continuous delivery was like just the next step that made sense. I think organizationally speaking, it provided a good sounding board. So it's like, hey, that does seem like a good idea. Let's keep doing that. And so, there are times where if you can work in a group, you can borrow people's courage, I guess, in that sense, right? So rather than being on your own and having to deal with pushing back on somebody asking for something faster, so that you're forced to sacrifice your personal integrity, you can lean on your teammates and get strength from them so that you can do a good job and do that together and feel comfortable doing it because they all agree with you. Because I think often people by themselves will feel concerned about what everyone else will think, and they also are comparing themselves to other developers with more experience than them and things like that. So they end up making sacrifices all over the place just to look good or comparable.
Yeah, I think that's a really good point. I've done a lot more pair programming than mob programming, but that idea of the reinforcement of, for want of a better term, the discipline around software development. If you and I are pairing, or working together in a mob and I'm having a bad day, you're going to pick me up and you're going to pick up the quality of both of our work, and vice versa. And that's important. And also the other aspect of that kind of those collaborative ways of working, which are deeply intrinsically linked to our ability to go fast with quality. The other aspect of that is the creativity that it espouses. I think we often don't think of our discipline as a creative one, but it deeply is. Just in terms of definitional terms of words, we're creating software. It's a creative discipline, but more than that, it's going to challenge us. It requires ingenuity, and it's not creative in the sense of art, because it's more difficult than that. It's done within technical constraints, as well as being beautiful and elegant and a nice place to work. It has to work and do something useful as well. And so this is a difficult thing. I think this is a hallmark of engineering. I think of engineering as a very creative discipline. So I think that's important. And human beings are at their best creatively when they are effectively playing and having fun and enjoying one another's company and bouncing ideas around between each other. I worked on a project which we built one of the world's, if not the world's, highest performance financial exchanges using continuous delivery from day one. We had so much fun. We were just bouncing. We did some genuinely innovative things in terms of architecture and approach. And we were just bouncing ideas around and having great pleasure in what we were doing. I can remember literally coming back from holiday looking forward to going to work. It was great times. And so I think this is important if we want to do great work.
Yeah, absolutely. And I think that kind of ties into what we were saying before earlier, where there's a lot of it goes with XP and continuous delivery, this kind of Zen, but also joy. It's the same thing, yes. Right? Like when you're not stressed out and you're making small changes, it's easier to be creative. It's easier to run an experiment. It's easier to bounce an idea off someone. Yeah. It's easier to think outside the box and attack the problem from a different angle. So I think, these things kind of have this feedback loop on itself to increase it or decrease it, and so I think that's definitely true. And and what you were talking about, Chris, what's funny is my story with continuous delivery and mobbing is, at least in my experience, was one for one. So I went from a place that had the dabbling in continuous delivery, but definitely not there. And then I joined a place doing mob programming. And the first day, in a language I've never worked in, we made a feature and released it to production. And I was just like losing my mind. I was just like, what is going on here? And you can really see why, because software is a lot of little changes often. And sometimes like one idea can take you on a course that's just going to be a gigantic batch. Like, what if we went about this feature by doing this? And it's just like, well, that's just going to cause shotgun explosion changes throughout the whole system. Like, why don't we approach it this way where we can keep it small, and those kind of things. So maybe it's a good time to transition topics. One of the ones you had listed was modern software engineering in a hyper-agile context. What are your thoughts here?
Yeah, so that flows on very well from what we were just talking about, I think. So I wrote a book recently, if you'll forgive me plugging my book, but it's called Modern Software Engineering, so hence the framing of this. But what I was interested in is what I said in the introduction. I was interested in the kind of principles that I've been doing professional software development now for over 40 years in one flavor or another. And over that time, I started to perceive some patterns. For a long time, I didn't believe that what we do is counted as engineering. And I think lots of it doesn't still. But I think that the step to Agile was a step in the direction of a more scientific style of thinking. Agile is largely about experimenting with ideas, inspect and adapt. You try stuff out, see what works, discard the things that don't. And I think that we can take more from science, the practice of science as a practical problem-solving technique, and apply more of that to software development. And I think that when we start thinking along those lines, what we end up is what we'd all call engineering. So I thought it'd be handy to try and define what that meant, to define what that meant in those terms. And that's what my book about. And that's come to deeply inform the way that I think about this, the way that I talk about it, the way that I practice it. So the stuff that we were talking about earlier, we were talking about things like making changes in small steps. Why does that matter? Well, it allows us to work more iteratively and to gather feedback, so we can learn from the things that we're doing. And I think that we spoke earlier about production lines not being applicable to software and so on, and if we are working in this creative discipline, solving problems that are technically difficult, technically demanding, and so on, then we are always about learning. We literally don't have a production problem in software, because we can clone, however big and complex our system, we can clone it for essentially free, because we can just copy the bytes and we can just get that clone of the bytes, put them somewhere else. We've got 2 copies of the system. So we never have a production problem. All of our problem is about design. It's all about design, and it's all about the creation of an idea into some executable form that we can run on a computer. So ours is a discipline that's deeply entrenched in learning. So first and primarily, we need to become expert at learning. And if we want to become expert at learning, then the granddaddy of learning, the best mechanism for learning that human beings have or have ever had is science. If you look at kind of human progress, almost on any scale, we've existed as a distinct species for around 200,000 or 300,000 years, and largely human history was flatlined for 200,000 or 300,000 years, and it started ticking up, a little bit. 10,000 years ago, we invented agriculture, and then a few hundred years later, we kind of got to some other things. But really, all of the progress that's happened in the 20th century and the 21st century, there's estimates that we double all of human knowledge every 14 months. It's an exponential growth. So if that's true, what kicked that off? And that was science. That's science that did that. That's the way that we solve hard problems. It's the way, virtually everything that surrounds us, the clothing that we wear, the watches on our wrists, the iPhones in our pockets, the computers that we're talking through, are all the products of this kind of engineering, scientific style thinking. And so that seems important to me. And so we can apply those learning techniques to software and we get better outcomes. And for that, we need to work iteratively so that we can work in smaller steps, observe the progress that we're making, and discard things that don't work and do more of the things that do work. We want to gather feedback so that we can understand the results of our iteration. We want to work incrementally so that we can step by step evolve the design of our systems, grow them, so that as you were talking about earlier, about not coming to the system and being scared to change it, because we compartmentalize it in a way that allows us the freedom to keep changing it over time. And then we want to work experimentally. We want to try things out. We want to think about controlling the variables, which goes again to working in small steps so that we can see the impact of our changes and so on, and working empirically, so discovering what's in production, all those kinds of things. And then the other side of that book is the idea of managing complexity. I would characterize quality in software as our sustainability to change it. I think as a practical definition, that's probably it. Everything else is kind of, we many of us kind of love code and love writing code and so on. I mean, we have aesthetics in code and all that kind of stuff. But practically, the reason why any of those things matter is because it allows us to understand the code and change it easily. And so in order to be able to do that, we need to manage it. We manage the complexity of that code so that we retain that ability on an ongoing basis to do that. And for that, we have ideas like, old ideas that have been around for a long time, but modularity, cohesion, separation of concerns, abstraction, reducing coupling, those sorts of things are foundational to our ability to keep changing code. And if we drive ourselves to improve the qualities in code that allow us to keep changing it, that improve, to reduce the complexity of the code that we're building, we get better systems. And the most profound technique that I know that allows us to do that is test-driven development. So if we count modularity, cohesion, separation of concerns, abstraction, and coupling as markers of quality in code, then how do we put that in? Well, we could be very talented, we could be very skilled, we could care a lot and work really hard, we could be smarter and do it that way. And people have. That's one way of doing it for sure. I'm not saying that there was no good code before test-driven development, but if we adopt test-driven development, writing the test first before we've got any code, that starts to impose certain approaches to design upon us, because it's really hard to write the bloody tests if we don't have code in a certain form. So what attributes of code make it testable? Well, it needs to be modular so that we can test it in pieces. It needs to be cohesive so that the pieces that we have are not deeply coupled somewhere else to some other bits of data or variables or elsewhere. It needs to have a good separation of concern so we can test these things in isolation of other parts. And it needs to be abstract so that we can understand the impact of changes in one place without worrying about their impact elsewhere. And it needs to be loosely coupled so we can pull these things out in order to be able to test them independently of one another. So test-driven development amplifies our talent as software developers. That's rather like other behaviors in other engineering disciplines. It allows us, it encourages us, even if we're not trying to do a better job. That's a pretty special thing right there. And I can't think of very many things that have the same impact. I'm largely an OO programmer, but I've done a lot of programming, so I understand the use of functional programming and so on. But the difference between OO and functioning doesn't matter in comparison to test-driven development. The difference between procedural programming and OO doesn't matter compared to test-driven development, because they don't amplify our ability to make progress in quite the same way. I think that the step to OO is a big step. I think the step to functional is a really useful step. But even so, they're not as big a step as the step to test-driven development, because that amplifies our talent as developers, and just picking up an object-oriented language or a functional language doesn't do that. But TDD does. So test-driven development doesn't make bad programmers great, but it makes bad programmers better, and it makes great programmers greater. So I say I don't think we have much that's like that, and that's really what I mean by engineering. What are the kinds of things that we're kind of thinking, the ideas that we can apply to software that are just going to improve our chances of doing a better job? And test-driven development, continuous delivery, optimizing for speed of feedback are some of the tools that allow us to do that. And what they do is that they allow us to work more iteratively and manage the complexity.
Yeah, and I like it. Essentially, TDD is a kind of a time. It gives you more time back later.
Yeah.
And other things may not do that, except for maybe like design patterns, for example, may give you time back later, right? So like things that you can pay yourself forward so that by the time you're ready to work on the next thing, it kind of multiplies your ability to spend time on things. So new abstractions or focusing on abstractions can be there as well. But yeah, certain tools are just maybe how things are organized structurally, and so they have different applications. But if you can always find more time for yourself in the future, that is a really great area to focus.
Yeah, absolutely.
Yeah,
and this stuff matters. Code is one of my other things. Is that I think that we often undervalue just how complicated software development really is. Coding's relatively simple in some ways, So the translation of an algorithm from a specification into a programming language is not the deeply difficult part. Learning the syntax of the languages is not really the hard part. Sometimes it's frustrating, but that's not really the hard part. The hard part is the way that we think about ideas and manage the information. The deeply hard parts in computer science are ideas like concurrency and coupling. And, those are just world-class difficult problems. As soon as you have information in two or more places that's changing, you're now into a complexity that's almost on the scale of, quantum mechanics. This is deeply difficult stuff. And we step into that whenever we create a thread and whenever we do a fork, in a version control system. So we are, as software developers, we are inches away from some really quite seriously, quite deep problems. And so working in ways that allow us to place some bounds, to limit the complexity, to think cautiously. And I think of TDD as one of the techniques that reinforces that too. It gives us that clearer picture, and it just simplifies the picture a little bit so that we can just proceed with that a little bit more caution. One of the things that I see in people that I think of as expert at test-driven development is just how tiny the steps that people like us take. I'm running my test multiple times per minute, as I'm developing code, and I'm doing a tiny change, running the test, a tiny change, and I'm running the test all of the time and getting that little dopamine hit of feedback that I know all my stuff's still working.
Yeah, for sure. Yeah, I mean, the introduction for TDD for me in my career was just such a joy. Like it really turned around my developer experience. That hit, that fun, and then you turn it up all the way and you have the tests running all the time, or there's different ways to do that. But yeah, I kind of circling back to some of your points earlier, right? So TDD helps you make all those small steps. It reduces the complexity and cognitive load. And so you're taking each small step with confidence. And it's just fantastic. And tying also back to continuous delivery. So it's no surprise that TDD is a very controversial practice. There's a lot of resistance in the community. But what's interesting is that I think continuous delivery, at least from a conceptual standpoint, people are, I would love to deliver, multiple times a day safely, right? And it's like, well, how do you do that? Well, that ties right back into, TDD is a great way to do that, because if you don't have the automated test there, then it's going to be really hard to do that safely, going back to very, safe versus dangerous continuous delivery. So I had one more follow-up question. I know we're getting close to time, but I thought I'd throw one more at you. So earlier you were kind of talking about modern software engineering in terms of learning and how critical learning is in the scientific method. And I was just wondering, it reminds me of something my daughter does, because I'll talk a lot about learning when I'm talking about work, and she'll make a joke with me like, "Oh, Daddy, are you doing learning time? Are you getting out arts and crafts?" So learning has this connotation in some circles, right? And so if you're speaking with executives or a crowd, how do you talk about learning where it's, maybe more suits the audience, I suppose, so if you have a more austere audience, how do you speak about learning to them?
I generally cheat. I talk about the commercial impacts and those sorts of things because they land. So if this stuff really works, and you're a non-technical executive in a big company and you just want software development that delivers better quality faster, you get more bang for the buck with your software development. Why would you care what all those techies are doing? Why would you care? So I try to steer the conversation away from that. It's difficult because I'm a techie, so I tend to fall back into using the language. And you're right, talking about learning scares the hell out of some kinds of strange people that I don't understand, and talking about experimentation scares people as well. And those I don't understand how you can be frightened of those when those are what make our world work, and certainly what makes software development work. So there's a degree to which you just have the conversations that you can have, and the good thing is, I think that one of the, you asked me right at the start, what I was excited about in the continuous delivery build. One of the things that I'm genuinely excited about is the Accelerate book and the DORA metrics and the State of DevOps report. This is a genuinely scientifically defensible approach to evaluating behaviors in software development teams. They've done 50,000 surveys over a period of years of different individuals, and they've built up using genuine sociology, the techniques of statistics that learn, and questioning and collection of data that they've learned from sociology, and they've applied that to our discipline. And the findings are astonishing. There are things that you can critique about it. It's sociology, it's not physics. It's, that's muddy, difficult, hard to experiment. There's things you can critique about it, but it's the best that we have. And it says things like, if you adopt the practices of continuous delivery, shorthand, my shorthand, they go into it in more detail. If you adopt specific practices, the practices of continuous delivery, and apply them to your business will make more money. Your staff will be happier. You'll have greater staff retention. The software that you create, you'll create it faster. The difference between high performers on the metrics that they use and low performers is that high performers will spend 44% more of their time on new features than low performers. These are big, important commercial impact kind of territory. So you can have that kind of conversation with non-technical leaders. Nearly always, in my experience, the very senior people completely get it. It's what they want. And the difficult group, the technologists get it because they're at the coalface and they're often suffering from inappropriate, inadequate approaches to software development. And it's the people in the middle that are the hard part, in bigger organizations at least, because their careers are built around the old model. The senior people are happy to change things because they want the business to do better. The people at the coalface actually doing the work want to change it because their lives are miserable. And it's the people in the middle who kind of got to a level where they're a bit comfortable. And that's dangerous. That's a difficult thing in terms of the being able to change this. But I think that the Accelerate book and the State of DevOps report, they're all one thing. There's the DORA group, which was started off by Jez Humble, my co-author for Continuous Delivery, Nicole Fosgren, Gene Kim, and they collaborated with a bunch of other people. But they started off this collection of data and this scientific study of what really works. And it's the best argument in many ways to kind of make a point. You don't win arguments with data. You win them with emotion, but you need the data as well, and the best source of data is the DORA metrics, as far as I know.
All right. Well, I think we're coming to time for the end of the show. Don't worry, we will forgive you for being silly and telling jokes. And anything that you want to plug or share before we wrap up?
I'll do a quick plug. So I've mentioned my YouTube channel already. So we've just passed 5 million views on the YouTube channel. We've got 128,000 subscribers. And we publish videos every week on topics related to the stuff that we've been talking about here tonight. I've also got a training site where we sell training courses, courses.cd.training. And we've got a summer special offer. So if you buy a course before the end of this month, you can get a second course for half price. So if anybody's interested in any of the stuff that we've been talking about, like to know about this in more detail, those are places to go and look. And if you want to know more about the engineering stuff, you can check out my modern software engineering book as well.
Awesome. And to our audience, if you know somebody that is doing things in big batches, or they're really stressed out about their next release that's going to come at the end of the next year and a half, then you might want to recommend this episode to them, and so that they can listen in. And with that, please like, subscribe, notification bell, all that. And then we'll see you all next time. Thanks for joining us. And thanks, Dave, for being with us.
It's a pleasure. Thank you. Bye-bye, everybody. Bye.